This lesson is on logarithmic differentiation. So what we're going to be doing in this technique is we're going to be using the laws of logarithms. We're going to be using the technique of implicit differentiation that we covered earlier in the course, and we're going to be using the derivative rules for logarithms that we have just taken a look at, and we're going to be using them to find the derivatives of complicated functions. So this is it's one of the reasons logarithmic differentiation is a good technique to know, is because it allows you to find the derivatives of complicated functions much more easily, and it lets you actually find the derivative of some functions that are impossible to find using the techniques that we've covered so far in the course. And the technique itself is fairly straightforward. All we're going to do is we're going to look at the equation that we want to find the derivative of. We're going to take the log of both sides and then simplify the resulting expression using the laws of logarithms. Then, once we have it simplified, we're going to differentiate implicitly, so basically taking it term by term and differentiating both sides of the equation with respect to x. And then we're going to rearrange everything to solve for the derivative that we're trying to find, which is the derivative of y for our function. So let's take a look at an example here. We've got a complicated function here, y equals e to the x, square root of x squared plus 1 divided by x squared plus 2 all cubed. You could find the derivative of this using the quotient rule, the product rule, and the chain rule if you wanted to, but we're going to see how it becomes a little bit easier if we use logarithmic differentiation. So step one, take the log of both sides. So on the left-hand side, we'll have ln y. On the right-hand side, we will have ln of this entire expression here. This one all divided by x squared plus 1 all cubed. And now we want to simplify using the laws of logarithms. So there's nothing we can do on the left-hand side. But on the right-hand side, we've got up in the numerator two expressions multiplied together. So we can write those as separate logarithms, which are added together. So that's going to be ln e to the x plus ln root x squared plus 1. And in fact, I'm going to rewrite square root of x squared plus 1 as x squared plus 1 all to the 1/2. And because that's divided by x squared plus 1 cubed, we can subtract the logarithm of x squared plus 1 all cubed. Oh, sorry, I wrote that as x squared plus 1. It should be x squared plus 2. And just let me check here. I did that in this step as well. Must have been looking up in the numerator. All right, sorry about that. X squared plus 2. Okay, now we can do a little bit more simplification using the power law of logarithms. So ln of e to the x, bring down the x, and then ln e is just 1. This is going to be bring down the exponent of 1/2 ln x squared plus 1. And then for this expression, we can bring down the 3, ln x squared plus 2. Now that's as simple as we can get it. So now let's apply implicit differentiation. So we're going to take the derivative of the left side and each term on the right-hand side. When we do this, remember that y here is a function of x. So we have to use the chain rule when we do the derivative of ln y. So the derivative of the ln part is going to give us 1 over y. Y is our inner function, so the derivative of our inner function, we can just write y prime. Derivative of x is 1. Derivative of 1/2 ln x squared, let's see. We're going to have the 1/2. We're going to have 1 over x squared plus 1 times derivative of the inner function is 2x. Minus 3 times 1 over x squared plus 2 times the derivative of the inner function, which is 2x. So we can simplify this thing a little bit. Do 1 over y primed, and we'll have 1 plus 1 over 2x squared plus 1. Oh, sorry. When I said it should actually simplify, that x and that x are going to, that 2 and that 2 are going to cancel, so I don't have that 2 anymore. I'm just going to have this x in the numerator. And then our next term is going to be, just multiply between the 2x to get 6x, x squared plus 2. Now, let's take this and let's solve for y prime. So, solve for y prime, we're just going to multiply both sides by y. And I'll just put this whole thing here in square brackets. X squared plus 2. Okay. Now, we could leave it like that, or we could put in explicitly what that function of y represents. So that's just our original function, e to the x root x squared plus 1 all over x squared plus 2 cubed. And all of that is going to be multiplied by 1 plus x over x squared plus 1 minus 6x over x squared plus 2. Okay. There's our final derivative expression. Now, this isn't a particularly compact or simplified expression. We could, if we wanted to, find a common denominator of all of these things inside square brackets. But if it's the kind of question where you just needed to find the derivative, or you just needed to, they give you a value of x to sub into the derivative, we could just sub it in from here and evaluate. So a lot of times you can do the derivatives of, it gives you another way of doing the derivatives of complicated functions that you could find the derivative of in a different manner. There are also cases where you have something like this, y equals x to the power of x, and you want to find the derivative of it. How would you do this? Because what kind of a function do we have here? We have looked at, in this course, we've looked at power law functions, which, fix that W, which look like something like x to the power of n. And then we have looked at, more recently, exponential functions, which are some number, let's say a, to the power of x. The way we tell the difference between them is where the variable is. Is it down in the base? Then it's a power law function. If it's up in the exponent, it's an exponential function. What if the x is both the base and the exponent? How do you do this? Well, logarithmic differentiation to the rescue here. Let's take the ln of both sides. Let's simplify using laws of logarithms. Nothing to do on the left-hand side. Bring down the x ln x. And now let's take the derivative. So, implicit differentiation, we're going to have 1 over y primed on the left. On the right-hand side, we have two functions of x that are multiplied by each other. So, we can use the product rule here. Derivative of x is 1 times ln x plus x times the derivative of ln x, which is 1 over x. So, we're going to have ln x plus 1 over y times y primed. Now we can just multiply, cross multiply by the y, so we'll have y times ln x plus 1. And then we could, if we wanted to, put back our original function, x to the x ln x plus 1. And that would be our final derivative. So, logarithmic differentiation, there is one question that appeared earlier on in the guide. If you're working on Unit 1718, Box D, question number 5, Part H is a good one to do using logarithmic differentiation. So if you skipped over that one because of the note that was left in there, maybe now you go back and try it and see if you can get the answer.